Okay, this is going to be a video lesson on the transformations of exponential functions. Okay, all right, so we got exponential functions look a little bit different because the variable is in the exponent. That's why it's called an exponential. Now, what you have, and this is something you need to understand, is that in the parent graphs, you have something that's called a horizontal asymptote, okay? And what that means is, okay, this is where the graph is going to get closer and closer to that amount, okay? And when you get to Algebra 2, they will go more in depth in that, okay? Now, very similar to quadratic, you don't have a vertex, but you have an absolute, you have an asymptote. Now, the idea is there's actually a point that's going to be right above that, and here's why, okay? All right, if I put in 2 to the 0 power, okay, 2 to the x, that's what I have. If I put in, okay, 0, all right, you would get an answer of 1. So that's why it's 0 over 1 up. Okay, so the graph will get closer to that and rise. Just because it's a 3, as you notice, it just rises faster. Okay, now, this right here, when this is a fraction, okay, all right, so when this number is between 0 and 1, okay, when it's between those, okay, what you have is something called exponential decay, okay? Now, exponential decay is often, you see that in nature, okay, breaking down of atoms or different things in the environment. This kind of function deals with growth, and you'll see that in investments. Sadly, in things like viruses, grow sometimes exponentially, okay? But just like that, they also have a horizontal asymptote, okay? And that goes this way, okay? Same thing here, horizontal asymptote. Now, let's talk about how you figure that out. So the bottom line is when you have this horizontal asymptote, let's say that's at y equals 5, then right above this at 4, your standard point is going to be. Same thing if this was like -3, then right below it would be -2. Okay, just so you have an idea, all right? Let's say this is y equals -3. All right, so what we want to do is we want to be able to identify the horizontal asymptote. Now, how do you do that when you look at the equation? Okay, very similar to with the vertex. Okay, all right. So the concept is, okay, this is opposite of -3, and this follows at -7. So this is just like the other one, opposite, follow. So on the graph, the idea is 1, 2, 3, 1, 2, 3, 4, 5, 6, and 7, okay? And you have a dashed line that goes through that. And then very simply, just go 1 point up, and your graph is going to go like this. So that's generally what's happening or taking place there, okay? All right? So you've got to figure out the horizontal asymptote. So my horizontal asymptote is at y equals -7. Okay, so this goes through 2, 5, and your horizontal asymptote is going to be whatever that number is. So in my case, it's 5. So it's the line y equals 5. This 2, 5 helps you figure out where your rise point is. Okay, so this would be -6, 8. So my horizontal asymptote's at y equals 8. Okay, so I got y equals, and whatever that amount is. Okay, so in this case it's -7. All right, this one, you don't have to worry about that. Okay, my point is 5, 1. My horizontal asymptote is y equals 1. This one right here would be -6, 0. So my horizontal asymptote is y equals 0. This point here, since there's nothing up there, that would be 0. This would be 7, so this would be y equals 7. Okay? Once again, there's nothing up there, so that's 0, and that's -8. So it's y equals -8. So what you need to do is you need to figure out both points. Both points will help you understand the graphs. Okay? All right? So go ahead and try to find some of the horizontal asymptotes. Okay? Now, we want to identify the transformations. Okay? So, and graph it. So here's what I'm going to do. Okay? My point here, 4, -6. I've got a horizontal asymptote at y equals -6. Well, how would I graph that point? Right 4, down 6. Okay, so right 4, down 6. Okay, this is where I draw my, let me draw it a little bit better. Okay, and then I just go 1 point up because it's positive, and this is what my graph is going to look like. Here, and I just boom, just like that. Okay, when you get into Algebra 2, you will graph that in detail. Okay. All right, this one, my point is -1 and 2. Okay, so my horizontal asymptote is at y equals 2. So -1 over, 2 up, and then my horizontal is at y equals 2. Okay, once again, 1 point up, boom, just like that. So how would I get to that? I go left 1, up 2. Okay. All right, I got this. Let's talk about this, okay? My point that I'd have would be 0, 8. My horizontal asymptote would be at y equals 8. Now, because of that negative, okay, how would I get to that point? I would go left, I do 0, I go up 8. And because that negative, I have a reflection. So let's think about what that would mean. For me, instead of my point being here, I'm going to reflect it below it. So it's going to go like this. And so my graph goes like that. Okay? Okay, now we have a decay one. Okay, so I have my point is -7, -3. My horizontal asymptote is at y equals -3. -7, -3, horizontal asymptote. Okay? Now, how would I get to that point? I'd go left 7, down 3. Okay, now, all right, so -7, so I'm right here. Now, since it is decay, I can still go this way, but instead of my graph going that way, it's going to go this way. Okay, exponential decay. All right, my point here would be 6, 0. That means it's y equals 0 for the asymptote. So 6, 0. Oops, that's 7. So y equals 0. Now, since it is decay, okay, so I just go right 6. Pretty easy on the transformation side. I go up here, and then this gets smaller. So the idea behind decay is it gets smaller over time. Okay, and go ahead and practice your exponential transformations and go formative.